Okay, we look at the next topic is on differentiation. Differentiation comes from a bigger topic known as calculus. So the whole idea of this chapter started from Isaac Newton. Okay, and okay, the idea is this. Basically, we are familiar how to calculate gradient of a straight line. And gradient of a straight line, the equation we are very familiar. So this is m1 is y equals to mx plus c. So that's not a problem. The calculation of m is change in y over change in x, or you call it rise over run. Simple. But now it becomes a little bit more tricky if it comes to gradient of, say, a curve y equals to x squared. So when we talk about gradient, we have to talk about the exact point that we want to calculate the gradient, and then we draw a tangent to that point. And then we calculate the gradient of the tangent, which will represent the gradient of the curve at that point, say x1. And the corresponding value of y is y1. So this is the idea behind differentiation. We are going to help simplify the calculations of the gradient of a curve at a particular point by coming up with a method to do it, simplifying it. And Isaac Newton did it. So let's just understand it this way. Okay, we'll look at y equals to x squared graph. The graph goes like that. And let's zoom in on one point. I want to calculate the gradient at this point. I call this x1. This one will be y1. So in order to calculate the gradient according to Newton's method, we are going to assume 2 points and draw a straight line and calculate the gradient of the straight line. Alright, so this first point would be x1, y1. This second point would be x1 plus delta x, y1 plus delta y. Make sense? Because this is increasing by delta x and increasing by delta y. This is delta y, this is delta x. So far okay. So to calculate the gradient, Newton included this term known as the limits. Limits of delta x approaches 0 for delta y over delta x. So by shrinking the delta x value, you can actually narrow the length of this straight line to as close to a single point as possible. That will help him calculate the gradient of a curve. So let's put this into calculation. So delta y is actually y2 minus y1 over x2 minus x1. So what is y2? y2 is y1 plus delta y minus y1 over x2 minus x1, which is delta x. So recall y is x squared. If y1 is x squared, x1 squared, y2 will be x plus delta x squared. So this whole thing is y2, x plus delta x squared. X plus delta x square minus x square over delta x. So let's just expand this square. X square plus 2x delta x plus delta x square minus x square over delta x. Can you see this? X plus delta x whole thing square is a quadratic function. I expand it and become x square plus 2x delta x plus delta x square. Can you follow? So this is just a plus b squared. A square plus 2ab plus b squared. And x square minus x square cancels away. 2x delta x plus delta x square divided by delta x. And I carry one more step, I cancel the delta x, I get 2x plus delta x. Agree? The delta x cancel. And if delta x approaches 0, what happens to delta x here? 0. So this whole term becomes 2x. So the gradient that we are calculating for this curve y equals x squared has a function 2x. So when x equals to x squared, gradient equals to 2x. Can you see? Based on this first principle of derivation, introducing the concept of limits. And for the purpose of this differentiation, gradient is given this way of expression: dy by dx is equals to 2x. So this dy by dx is what we call differentiation of y with respect to x. We differentiate the function y with respect to x. So this is for y equals to x squared. So if we always use the first principle, it's a very tedious process to get to a gradient expression. So this kind of differentiation, when we have y equals to ax to the power n, when you differentiate, you bring the n down, simplified, n times a, x, and the power of x now subtract 1. So this is the method for differentiation of polynomial. Differentiating y with respect to x, you take the power of x, bring it as the coefficient, and then the power you subtract 1. So for example, I have y equals to 4x cubed plus 3x squared minus 7x. So when I differentiate, what do I get? Repeat this formula 3 times. 3 bring down, what do you get?
3 times 4.
Which is 12x. Do you still put a 3 here? No, it's a
3 minus 1.
square. Plus 2 bring down, it's a 6x. Power of 2 minus 1 is 1. Minus 7. 1 bring down times 1 is 7. X power 1 minus 1 is 0. So x power 0 is 1. Leave it as it is. So this is the first derivative. We call this the first derivative. You can differentiate one more, fine, if you want. But this is the gradient of the graph y equals to 4x cubed plus 3x squared minus 7. This is the function. It's not an exact value. it's a function in terms of x. So depending on where you want to calculate the gradient, you substitute the corresponding x value into this function, you get the value of the gradient at that exact point that you want to calculate. Okay.